Today I'm going to try to convince you that two-dimensional motion is just a combination of two kinds of one-dimensional motion. I'm using an application called interactive physics, which allows me to set some initial parameters and then to run a simulation. So for example, let me begin by creating an object. There it is. And if I come down here, I can run and we can see what the object does. So what's going on here? Well, up here under the world menu, I can show you the gravity. Looks like we've got vertical gravity, 9.8 meters per second squared down. And air resistance, no air resistance. So we're basically looking at free fall here. So I'll run it again. You can see that. Stop it. Bring it back to the beginning. And now I'm going to try to make things a little bit more interesting. So I'm going to create a second object, put it right next to the first one, and over here I've got this menu and I can adjust the initial velocity of this second object. I'm going to set it to 5 meters per second. Now let's watch what happens when I run the simulation. It's a little bit fast, but you might be able to see what's going on. I'll run it one more time and then I'll slow it down. So you may have already picked up that the motion in the vertical direction for these two objects is just the same. You can see that at any moment in time, the vertical position of these two objects is the same. And furthermore, if you watch the vertical velocity vectors, you can see that they're the same at any particular moment. So let me dress things up a little bit more. I'm going to create one more object and I'm going to try to move it. There we go. I'm trying to move it so that it's right above this one. And I'm going to set the initial conditions to 5 meters per second in the x direction, 0 meters per second in the y direction. And I'm also going to set the mass to 0. Now the program doesn't really like this move, but what this does is it basically means that this object won't be affected by gravity. So let me hit play here and you can see it's trying to keep me from doing this. Results will be unpredictable. Do you really want to do this? Yes, I do. Shoots across the screen. I don't really know why it does that, but what I really wanted to show you is now it won't be upset anymore. There we go. That's what I really wanted to show you. Let me run it one more time. And I hope that you can see that not only is the motion in the vertical direction the same for these two objects, but the motion in the horizontal direction is the same for these two objects. So let me run this in slow motion, and you can see that at any moment in time, these two objects are in the same place and have the same velocity horizontally. These two objects are in the same place and have the same velocity vertically. So you can see that we can consider the motion of this projectile to really be a combination of two kinds of motion, what's happening in the vertical direction and what's happening in the horizontal direction. Okay, so let me try to illustrate this point a little bit more. I'm going to get rid of this object and I'm going to change the initial velocity of this one. I'm going to set the y velocity to 6 meters per second. I'll run the movie and you can see this time the vertical velocities have nothing to do with each other. I'll run it more slowly. Look at that. They're not in the same place. The y velocities aren't the same. It's just totally different motion. So now let me change the y velocity of this object. You probably won't be surprised that now I'm going to put 6 in here. So now these two objects have the same initial height, the same initial velocity in the y direction, and when I run the movie, you can see that they are indeed in the same place with the same y velocity all the time. Let me run it in slow motion, and you can see that it's really true. So that's about all I wanted to show you today. Hopefully you are now convinced that two-dimensional motion is really just a combination of two kinds of one-dimensional motion. For projectiles, in the horizontal direction, the projectile has no acceleration, and in the vertical direction, the object will be accelerating at 9.8 meters per second squared toward the ground.